I just uploaded it once. So we are asked here to find the relationship, an equation, a linear equation. Linear, we're told it's linear. The differentiation is linear. Find an equation that fits the information given in the problem. And then when will the value of the car be 0? And when will the value of the car drop to 2,000? 2 other questions added in. So how do I address this? What is given in the problem? So look at what we have and
2 points.
perfect. Can anyone give us the 2 points? 0, 13,000 and 5, 7,000. Awesome. So then I will have to determine the slope. Do you expect the slope to be positive or negative?
Negative.
Excellent, wonderful. So 7,000 minus 13,000 divided by 5 minus 0. So then the numerator is negative 6,000 divided by 5. And that's negative 1,200. And if you just write negative 1,200, I cannot give full credit. Because when you call me and you say, what are you doing? And I say, I'm driving. And you ask me, what is your speed? I'm not going to say 50. I'm going to say 50 per hour. So what is this? Dollars per year. So this is how much it depreciates per year, for each year. Okay. So now this is the y-intercept. So therefore, we're going to use y equals mx plus b. So then y equals negative 1,200 x plus 13,000. So now, if I ask you what does 13,000 represent, you will say it's the y-intercept. If I ask you what is the slope, you'll say how fast the value decreases per year by $1,200. Yes, please.
So you know the other equation, y minus y1 equals that. If we use that for this, would it still work?
It's the same thing. It doesn't matter. You're using the information from the, yes?
So if we have point other than 0.
I'm sorry?
In that situation, like we will apply the other equation, right? Y minus y1.
That equation is applicable for everything. Any point including this one.
Okay.
But the easy one is applicable only here.
Okay, but in case if we don't have 0.
Yes, you will be using y minus y1.
Okay.
Yes. Okay. So now let's say another question is when the value is 0. The car I drive is in minus. It passed that 0 a long time ago. I have to pay you if you'd like to get it from me. So then 0 equals negative 1,200x plus 13,000, and negative 13,000 equals negative 1,200x. So then x equals 130 over 12. How many years is that? Whatever. And now another question possible here is when will the value be 3,000? How do I determine that? When is the value 3,000? Yeah, the same thing. So it's going to be 3,000 equals negative 1,200x plus 13,000, which will be negative 10,000 equals negative 1,200x. So x is 100 over 12, whatever that is.
So for x, if we're asking how many years would it reach, that's where we have to plug the numbers to x to find the y.
No. That question would be find the value of the car in 5 years. And you plug in 5. Or find the value of the car in 7 years, and you plug in 7. Okay, so let's think of one with quadratic. So let's look at one with quadratic. So let's look at a function that has a maximum, which is, let's say, f of x equals negative 0.01 x squared minus plus 10x. This is a quadratic function with a negative slope, which makes it having a vertex that is a maximum. So let's suppose I throw a ball up and outward, and it hits the ground eventually. I would like to determine the maximum, and I would like to determine where it hits the ground. So how do I find the maximum of such a function? Very good, awesome. Negative b over 2a. So be very careful, because sometimes functions are not given to you in descending order. This one happens to be. So negative b over 2a. So this is 500. So then f of 500 will be the maximum height. And you just plug it in.
So we solve for x, or no, it will give us.
So x is 500 feet, and we want to determine the maximum height by plugging it in.
Okay.
So that's a typical situation with a model that is quadratic. Next topic, please. It's such a rushed course. Forgive me for saying that. I didn't have the time to breathe or tell you a joke every now and then.
So this is like max is 500?
No. Very good. So I'm standing here. I throw the ball up in the air. 500 feet away from me, it will reach its maximum.
Or is at 500 is the
F of 500 would be the maximum.
Can we just solve that to see what it is?
2,500.
and that 500 is how far is the
How far from where I stand, it reaches the maximum. So it's something like this. This is 500. This is 2,500.
Isn't x usually the time? Exploring.
For this particular, very good question. For this particular situation, x is the horizontal distance, and y is the height. But you're right, there are other possibilities. This is not the only one, where x is the time. Very good. And if I want to determine how far it reaches or touches the ground or hits the ground, then I have to find f of x equals 0. Negative 0.01 x squared plus 10x equals 0. Again, allow me to suggest you will develop your own style, but I refuse to solve a quadratic equation with a negative leading coefficient, so I will multiply by negative 100. So x squared minus 1,000x equals 0. This is way more human. So then the parabola looks like this. 0 here, 1,000 here, 500 of course right in the middle, and this height is 2,500. All in feet. Anything else that you would like to review? I am begging you to redo all problems from all tests as many times as you need. I posted all solutions for, and I will post on Saturday, we'll post the solutions for test 4. Please.
What is the difference quotient? Is it when we divide, and that's the quotient?
Right? Let's look at, can anyone give us a function, any type of function, any function. So we can determine the difference quotient, which you do not have to memorize. In the next class, you have no choice, though. So can anyone give us a function? Any function you can think of. And the difference quotient will be given to you in the problem. F of x plus h minus f of x divided by h. two things have to happen when you simplify this. One, all terms from the top without h must go away. Go. And the second thing that happens, this h must go as well. There is still h left in the problem at the very end after you simplify it, but not that one from the denominator, not that one. Okay, can anyone make up any function you want? Rational, quadratic, radical.
So our answer
Yes?
will not contain h. That will mean
H will be in the problem, but not this one.
this one.
Not this one. Not this H. H is still in the problem, but not that one. That one will go away.
So our answer it will have h in the denominator.
No.
Oh yeah.
Not the one that you see in the denominator. That one must go. Any function, please. You know so many functions. I know you do. Okay. X minus 1 over 2x plus 3. What type of function is it? Very good. I have this, I don't have this. So this is f of x plus h, which is x plus h minus 1, 2x plus 2h plus 3. So then the difference quotient will be x plus h minus 1 over 2x plus 2h plus 3 minus x minus 1 over 2x plus 3. The next step is to find the least common denominator in the numerator and the necessary adjustments for the top. Two x plus 3, 2x plus 2h plus 3. This one gets a 2x plus 3. And of course, this one gets a 2x plus 2h plus 3. Ready? So 2x distributed here, 2x squared plus 2xh minus 2x plus 3x plus 3h minus 3. Minus, of course, I'm going to run out of room. You know me already. So negative 2x squared minus 2xh and minus 3x. And plus 2x plus 2h plus 3. All terms without h must go away at the top in red. So these two go. This is a bonus. These two go as well. These two go. These two go. These two go. Wonderful. So at the top, we only have this and this, which makes a 5h. So 5h over. I flip the denominator. H, 2x plus 3, 2x plus 2h plus 3. I simplify. And there is still h left in the denominator, but not this one. That one went away. So this is the difference quotient simplified, fully simplified for a rational function. I know it's been a while since we looked at this, but this is, if you understand this, you know half of Calc 1. I am not kidding. Half of calculus deals with this. Okay. Anything else? Yes. Deja? Yes, please.
I forgot
Piecewise.
what it's called, but it's like for it's can't remember, but it's like recurrent, E equals P R P E raised to the RT.
Oh, the exponential growth, exponential decay.
Exponential growth.
Okay, good. Sarma, you wanted a piecewise defined function. Okay, and okay, very good. So let's look at a exponential growth model. Okay. Here I have one. And let's see if you if this is something you would like to work on. This is test 3 from a totally different class. I was wrong. I thought I had one like that, but no. I have a logistic growth model, but that's not what you wanted. But we can go back to our previous test, right? That was in test 2. So this is an example of what we just did with the depreciation. And this is an example of what we just did with the bolt's horizontal distance. I guess it was on test 3 then.
The first question.
Test 3, right?
First question.
No, that's not what she meant.
Yeah, that was
No, that is.
PE off.
No, this is what she meant. Is it? The exponential decay. You're not talking about the investment.
PE to the power of RT.
This is it.
Is this a piecewise question?
No.
No, we're talking about something else, and then we're going to look at the piecewise.
This one. I'm sorry. You can go with that.
So it's this one, right?
Yeah, that's the one, but I already got that.
Okay, we can look at the other version. Let's look at the other version. Yeah, we had, oh, this was version 2, right? Oh, it's test 3, right?
Yes.
Yeah, we had that with cats. And I misspelled it, and for some reason, I don't know why. Oh, I changed it. I corrected it. Okay, so the stray cat population grows exponentially in a small town, blah, blah, blah. So we have, the model is given to us. So A of t, A0, e to kt. Okay. So we're told that the growth rate per year is k, which is 0.15. Find the function that models the stray population after t years. So it had initially 30. So the first thing we have to write is that A of t equals 30 e to 0.15 t. And that's the model. We're given the initial size of the population, and we're given the growth rate. That was part A. Is that okay? Okay. Now in part B, it says find the projected population after 4 years. All I have to do is just plug in 4 and plug in the calculator as 30 e to 0.15 times 4 and find the number. Is that okay?
Yeah.
Find the number of years required for the stray cat population to reach 500. That's a different story, and it's slightly more difficult, right? Because this time I have 500 equals 30 e to kt, 0.15 t. So first I have to clean it up. It is mandatory to divide by 30 first. So then we get 50 divided by 3 equals e to 0.15 t. And then we have no choice but to apply natural log to both sides. When we do that, we have natural log 50 over 3 equals 0.15 t, where t is natural log 50 over 3 divided by 0.15. Now, be very careful. I caution you with how you put it in the graphing calculator. It has to have at least parentheses around the argument of natural log. To be safe, I would personally, depending on your calculator, I would put all these. Yes, you can say it's not required, the denominator is only one number. I would have to say yes. I would have to say you're right. But again, be careful. Is this what you meant?
Yeah.
Other questions? And we'll do the piecewise in a second. Other questions for me?
The transformation.
Yes, and transformations. Deja?
I'm good.
You sure?
Yeah.
Okay, so let's look at the piecewise defined function. Very important for for calculus. Very important. So let's find one branch, two branches, three branches, whatever you want. So please make one up.
X squared plus.
Plus 4.
Okay.
For x greater than or equal to negative 2.
Do you think it would be okay if we do cubic, or is that too hard?
No, that's fine.
Then x to the power 3.
Okay. You want 2 branches or 3 branches? Okay. So between, so that's greater than negative 2, so let's say negative 4 to negative 2. And less than or equal to negative 4. The square root of negative x. So we created a function that is defined on all real numbers. Here we have negative 2 to infinity. Here we have negative 4 to negative 2. And here we have negative infinity, negative 4. No gaps whatsoever. From to the left of negative 4, in between negative 4 and negative 2, and to the right of negative 2. So we know that there are 2 key x values here. One of them is at negative 4, and the other one is at negative 2. And also 0 has to be in the table. So under negative 2, I will be copying these symbols in case you are using my method. Under negative 4, I will be copying this to the right and this to the left. I will write just to make sure, because intentionally I wrote that function that is not in the correct order. So between negative infinity and 2, I will have to use x squared plus 4. Between negative 4 and negative 2, I will use x cubed. And between negative infinity and negative 4, I will use the square root of negative x. So now I just pick numbers and plug it in. So I will use negative 9, and when I plug in negative 9, I get 3. When I plug in negative 4, I will get 2. When I plug in negative 4, I get a huge number, so I get negative 64. Huge for my table, for my graph. When I plug in negative 2, I get negative 8. When I plug in negative 2, I get 8, and when I plug in 0, I get 4. So now all I have to do is just graph. You'll see what happens and how you read limits in the next course from such a table. So that's why it's so important. Okay, so so I have to go as low as negative 64. I have to plot negative 9, so let me see for a second what scale should I use. And be careful with the scale. You should always think before you start graphing. Or if you don't like that little little coordinate system that I created for you in the test. Cross it out and put your graph on the scratch paper. It's up to you. You don't have to use that if you don't like it or if it doesn't fit. So negative 64, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So each negative 16, negative 24, and so on and so forth. So on the x-axis, I have to go to 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. Okay. So from left to right, negative 9, comma 3. Negative 4, comma 2. And it's a full point. And here's the graph. I'm done with that. The next piece of the graph, negative 4, negative 64. And it's an open point. At negative 2 is negative 8. And remember the graph of x cubed. So here's the graph of x cubed. But this is only between this piece and this piece. That's it. It should continue here, but of course I can't. Okay, so now negative 2, comma 8. 4, 5, 6, 7, 8. It's a full point. And 0, 4. Okay. So this is the graph. Yes, please. Okay.
Should negative 2, negative 8 be also not within point?
Say it again.
Should the negative 2...
Yes, yes, you're right. That is an open point. Yes. The full point is here. Yes, this has to be an open point. Thank you. Both of them here have to be open points. Thank you. Otherwise, it's not a function. By the vertical line test will not be a function. But if this is full and this is open, it's a function. Or vice versa. If this is full and this is open, it's still a function. Yes?
Could you say the last one that you...
X squared?
Yeah.
Okay, x squared up 4. X squared up 4.
Yeah, that's what we know from transformation, but how to plot these points.
Yeah, but I have to graph it between negative 2 and infinity. So it's x squared up 4, but only between negative 2 and infinity.
Like which points we do? Like -2 and 8? Or
Yeah. Negative 2, 8. It has to come down to 4, the vertex, and then goes up. Okay, one more time. Here's the graph of x squared. Here's the graph of x squared plus 4. So it starts here, comes to 4 and goes up. Or starts here, comes to 4 and goes up. This part does not exist. I have to graph x squared plus 4 between negative 2 and infinity. Better? Hold on one second, fill in.
Yes. Can we try a 4-piece one, or do we not have to do that?
It's the same thing.
No different.
So if we were given this as a problem, what would we be given? Would we be given the pair, and then we would be...
You will be given this function, nothing else.
Okay.
You'll be given the function to graph. Imran, is this okay? So I have to start here But I cannot graph anything else. I know what I have to graph. It's x squared up 4. And it has to start here, comes down to 4, goes up to infinity. The entire graph should be this, but I can't. I cannot go beyond to the left of -2. Because it's only between -2 and infinity. Someone else had a question. Connor, did you have something?
No, that was.
Okay. Anything else? Other topics? We have about 5 minutes, so let's see if we can do anything else. We did a piecewise, we did a rational. Oh, you said transformations. Do you have in mind something? Any particular function or type of transformations you would like to see? With which function we would like to use for transformations? Yes, Flynn?
We tried dilations. And we tried dilations.
Just stretching.
Right, but first give me the function. Which function you would like to use transformations on? Log, exponential, cubic, absolute value, quadratic, log. Okay, I needed that first. So we want to use log. We want to use log or natural log. Or we want to use a base less than 1 or a base greater than 1. Greater than 1, okay. And can anyone give us the function?
So can you use quadratic function for this? Quadratic.
Quadratic. Okay. Are you okay? Is everyone okay with switching to quadratic? Okay. Okay. Yeah, right.
It will solve both the problems, man. Both problems. We need to see the quadratic as well and log as well.
Yeah, we should do that.
So just give me the function.
X cubed plus 4x.
We can't. It has to have transformations. If you give me, for example, x squared minus 6x plus 8, I have to complete the square first. I can't use transformations if you give me. Very good question, actually. So if you say graph 2x squared plus 4x minus 3 using transformations, I'll say absolutely not. I can't. It has to have the completed square. Something in front, plus or minus, whatever, plus or minus outside. But if it doesn't have the completed square, then I have to spend 5 minutes and complete the square first.
Okay,
I can use transformations on this.
Okay, square root x squared plus 4x. Yeah, minus sign outside.
So you said x
Plus 4x and
plus 4 squared.
no, just 4 all here.
If it doesn't have a completed square, I can't.
No.
I mean, I can, but I have to complete the square first. And what is outside? Plus? Plus what?
5.
Plus 5. Very good. So you immediately should remember that the vertex has to be this, as a check mark, right? Then the base function, we know it's x squared. The first transformation is x plus 4 squared, which means left 4. Then I have to reflect, and that's the correct order of operations, reflect with respect to the x-axis. And number 3 will be negative x plus 4 squared plus 5, which means up 5. Yes, Flint, go ahead.
Do you want us to write out each and every step?
Yeah, somehow you either graph it or write it and graph just the final, or you graph some of you did very nicely. I really enjoyed that. You graphed and you said you graphed everything like I listed them, and you put number 1, number 2, number 3. That's fine. So you did 2 things in one. You told me the order, and you also graphed them. I saw that many of you did that. So it's up to you, but you have to explain the order somehow. So when we graph, we have this is x squared. This is at -4, so this is x plus 4 squared. Then you said to reflect. And then up 5. 1, 2, 3, 4, 5. So this is final. As we expected, the vertex is at -4, 5. But you understand why I couldn't do anything without if the square is not completed, I can't do anything. I can't use transformations. I mean, I can, but I have to first form the perfect square and then use transformations. Yeah. So it will take a while.
And we should also label